Okay, so let's start. Is my screen visible to you all?
Yes.
Okay, so one of the doubt which was posted in like last week's doubt solving forum was that how the load is being transferred in this video here. So this is the basic structure of a composite, and when we are trying to construct a laminate, that is, we'll have fibers arranged in different orientations in each of the composite layer. For as seen in this 3D plot, these are the fibers which are arranged at 0 degrees. This is the application direction of the force. As the fiber orientation is same as the force, that's why these fibers are said to be in 0 degrees. Then this yellow section is the matrix medium, while black section are the fibers. In this case, I'm taking carbon fibers. That's why they are taken as black. So we have matrix region and we have fibers here. First line is in 0 degrees. Then second line, we have fibers oriented at 60 degrees. And in the third line, they are oriented at 90 degrees. So the front view of this laminate is shown here. So composite stacks could be of two type. One is lamina, which is when all the fibers in a given composite will have same orientations. The number of layers can be many, but all of them would be either in 0 degree, 60 degree or such directions. But in case of laminates, we have them in different directions stacked one over another. So we can see there are three layers in this particular composite. In this diagram, I have changed the colors of each and every angle. So we can see this one is black, which is like it depends on the angles you are taking. You can either take it as 90 or you can take it as 0, but you should fix one angle which you are taking. So for example, if this one I'm taking it as 90, then the one which is lying horizontal would be 0 and the center one would be 60. But if you are taking this one as 0, then this would be termed as 90 and this one be termed as 30. So it depends on the axis from which you are measuring the angles. And then the composite will bear stress in different directions. So we can see that the force is applied along this y direction. And here the fibers which are there along this direction of this force will bear maximum amount of load. So under the application of this particular force that is along y direction, forces in individual fibers would be along this direction and this direction. But in case of matrix, all the loads would be in all the directions as matrix is isotropic in nature. So we can see here fibers will bear loads, like most of the load will be bore only along the direction of the fiber, but in case of matrix the load would be bared uniformly in all the directions. The simple difference is because fibers are unidirectional, so they are anisotropic, while matrices are isotropic and they bear in all directions. So when we apply force, we can see here the fiber on application of a particular load, that is force per unit area. So along for this particular stress, the fiber will elongate as shown in the deformed structure, this black transparent structure. So the fiber will elongate up till this. The matrix is tightly bound to this fiber surface. So the matrix will also have same strains which are generated in the fiber, and therefore same elongation would be seen in the matrix component. So we can see if fiber has been elongated this much, the matrix will also be elongated to the same extent because there is strong interfacial bonding between the fibers and the matrix. So once the matrix is also that much amount of strain, though, so on the basis of the Young's modulus of this matrix, the stresses will generate in this particular matrix medium, which would then be transferred to the next layers or the fibers which are parallel to this particular fiber, and thus load would steadily be transferred. So matrix is very important for transferring the load because fiber will bear load only in one direction, but matrix will bear uniform load in all the other directions too. So if we have a composite laminate which will have fibers in only one direction, then as soon as we change the direction of application of force, then the entire strength will only depend on the matrix system. And that's why matrix is very important for load transfer. Okay, so this was the like FESEM images which I also showed in my last doubt solving session. So this is the cross sectional area of fibers. We can see these fibers are strongly bonded with this matrix medium. So if we stretch fibers in the outward direction or along the axis anytime, then the matrix will also stretch along with this because they are tightly bounded together, and the stresses will be generated in this black medium which will be transferred to the fibers which are adjacent to this particular matrix, and thus stress is equally transferred in the entire composite medium. Okay, so that's it. Do you have any other doubts regarding this week's like course whichever sir taught? Or do you want me to explain anything more about this load transferring in matrix? People respond. Hello, can you hear me?
Can you explain it once again?
Yeah, sure. So, um, so I started from here. The composite will have fibers in particular direction in a given composite layer. This is known as ply. That is the layer in which all the fibers are in same direction. Uh, This is also known as laminate, that is AE at the end. Then we have the composite which has all these different laminates placed one after another at different angles. So the matrix is there to bind each of these fibers at different angles together. So when we apply force at a given direction, then the fibers which will be there in a direction same as the applied force will be a maximum load. As we can see in these properties, the longitudinal modulus, that is the modulus, which is ratio between the stress applied to the elongation generated in the fiber, its maximum along the direction of the fiber, and along the transverse direction it's quite low. So this is how the fiber looks like. It's similar to a root. So if you can see, if you'll apply a load along this direction, that is across the axis, then this fiber would be able to bear a lot of load. But if you try to apply load along this direction, then this fiber will simply start separating. If it's there in combination with matrix, then also it will not have that strong load bearing properties as compared to what it had in this particular direction. And therefore, longitudinal and transverse modulus vary a lot. So, due to this difference, when manufacturing composite, matrix are very important. As fibers will bear most of the load only along this direction, we need matrices so that if forces exist in other direction, they can simply be transferred to layers which are there at different angles. So this particular fiber will have sine theta components and cos theta components. So if the force is applied along this direction, that is x, or z, then the cos theta and sin theta components, whichever will match in that particular direction, will start providing support to this particular composite. That's why the isotropic nature of matrix and the anisotropic nature of these fibers perfectly complement each other and provide highest strength which is required in a composite. Fine. Then this was what I explained, that if stress is generated in a fiber, it will elongate, it will generate corresponding strain. Like we'll see elongation in that fiber. Then after elongation, the same thing would be transferred to matrix component as they are both strongly binded together. This matrix component will transfer stresses to the fibers which are present nearby, either at different angles in the adjacent layers or the fibers which are placed parallel to that particular matrix material. So that's it. So any other doubts?
Thank you, ma'am.
Okay, welcome. Ask if you have any doubts. I mean, most of you would have gone through the lectures which were there in week two, right? And they were only on manufacturing of fibers. So yes, there would not be any doubts. Okay, fine. Then can we end this meeting? Hello.
Hi, ma'am. I'm having
Hello.
couple of questions.
Yeah, ask.
So basically, ma'am, actually currently I'm living in the UK. So my question is not related to this session. The I'm having the questions related to the course. So the final exam is the face-to-face exam, or we should come to the centers, right? So is there any option for the online examination? Because I cannot attend the physical examination because I live in the UK. Is there
Okay.
any option for online examination?
Um, if there are special cases, I think there might be options. I'll discuss it with sir and let you know.
Yeah, ma'am, please. So means if you confirm that I can attend the exam online, then as soon as it is possible, I will book the slots for it.
Yeah, sure, sure. You are Shubham Patil, right? Okay.
Yes, yes.
What is your NP? Do you get some NPTEL ID or something when you're logging in for this course?
I need to check, ma'am, but
Or mail me?
I think I got uh, just give me a second. No, I did not get anything.
Okay, fine then. Mail sir. Yeah, you can mail sir. You'll get his email ID on IIT Kanpur's website, and I'll also pitch the
Okay,
same thing which you explained to me. We'll bring out a solution for you.
okay, ma'am. Yeah,
Anyone
sure. Thank
else?
you, ma'am.
Do you have some doubts?
Ah, yes, madam. One doubt is that
Okay.
actually in assignment one,
Hmm.
actually it is coming that which of the following material is not composite material.
Yeah.
So in that connection, the two answer looks it is okay, but here the choice we have to make one. So example is giving the polywood and the granite and the polyethylene tetra PET,
Terephthalate.
and
Yeah.
one is the glass fiber. Glass fiber is a fiber, and the PET is a resin of the
Resin.
polyester. The
Yes.
granite and polywood, they both are the composite material. It
Yes.
looks like the two answer is correct. So, what, anyone you have to precise?
I think maybe that fiber, glass fiber is a misprint, which is actually fiberglass because glass reinforced composites are also known as fiberglass. I'm not sure, but I'll check it with
Okay.
sir and let you know.
Actually, that GFRP you are telling that GFRP, glass
Yes,
fiber
yes,
reinforced
yes.
plastic.
Yeah.
Reinforced plastic means we are thinking that this is a composite material. Like CFRP, carbon fiber reinforced plastic. So these
Yes.
are the composite materials. So glass fiber and carbon fiber, these are the fibers as like that. And the
Yeah.
PET is like a resin. It is a thermostat, thermoplastic type of resin looks.
Yes.
So in that connection, two answer it looks.
Yeah.
So
C
madam,
and
please
D both
clarify
would
in that.
be correct. Yeah, you're right. It might be
Yeah,
a
C and
typing
D,
mistake from their
yeah.
end.
Please that way.
Yeah,
And
sure, I'll confirm.
but different type of glass and C, D, E, like that is the different type of glass.
Yeah.
And that can be just little you can clarify that.
It depends on the manufacturing technique that what is the glass which you're using. It's just the different, what you can say, grades of glass. All are SiO2, but the grades differ. I mean, the additives which are using or the heat treatment conditions which are using that will differ. On that basis only, we have E glass, S glass, C glass, D glass. So there's not much difference. The properties would all be same, and even the strengths and moduluses will lie in similar ranges. The only difference would come into like few like specific properties or the coatings which are there on those fibers, so their compatibility with particular matrices may vary. As such, you just need to
Okay.
know four main categories of fibers. One is carbon fiber, one is aramid fiber, that is like Kevlar kind, one is boron fiber, and one is glass fiber. The rest further subclasses are all which like minutely differs in their properties, so it doesn't make a lot of difference.
And then one more, madam. Actually, that carbon and graphite is from same family. Means
Yeah.
that is all are amorphous material, and the carbon and graphite. Yeah, that is you can a little bit explain that glass fiber and carbon and graphite, which is the category like that. Amorphous or amorphous, and the other one is the polycrystalline. Polycrystalline, the difference. And
Yeah.
the glass fiber can be used for the thermal insulator or not. That they are not able to get any. Just you can give you the brief idea that
Okay.
thermal insulator can be used or not, and the glass fiber that a high ratio of surface area to weight, and that it is there or not. We are not able to get in books. Can you just explain?
So see, glass. First, I'll solve this like high temperature operation with. Then we'll move to difference between carbon fibers and graphite fibers. Okay. So when we start with glass fibers, so we can. So we already know glass fiber is that silica based fiber. While so normally when we think about applications relating to composite, then high performing composites are made out of carbon fiber. The ones which require more abrasion resistance, like bulletproof jackets, helmets, and something similar, require Kevlar fibers. And the ones which require like approximate strength, that is not very high and not very low, then those are glass fibers. Glass fibers are comparatively heavier, like their density is around 2.56 or something, while the other fibers are 1.8 or something. So that's why glass fibers are cheapest and they are most commonly used fibers, but their degradation temperature or maybe melting temperature is 600 degrees Celsius. But when we talk about Kevlar and carbon fiber, then it's only 400 degrees Celsius or sometimes even lower. It can even be 300 degrees Celsius. So that's why when we compare these three categories, that is carbon fiber, aramid fiber, and glass fiber, we consider that glass fibers can be used in a better way for high temperature operation because they can go up till 600 instead of 400, which is there in case of carbon fibers. Apart from that, there's no such actual bifurcation. If you want even higher operation ranges, then you should switch for metal reinforced matrices or ceramic reinforced mattress composite instead of these polymer reinforced. Fine. Am I clear? Or you have some other doubts on this? Hello, Krishna. Have I answered what
This
you
is
were
application.
asking?
Madam, just little. What I understood that this is the application of the different advanced fibers.
Yes.
Okay, temperature limit that we understood. Then
Okay.
other things I want to know that actually that the glass fiber are useful in thermal insulator or not? How that it is actually the thermal insulator or it is a thermal a good conductor for the thermal application.
Oh, that we already know. Silica as a substance is insulator. But when we talk about graphite, then graphite is a very good conductor of heat as well as electricity. But silica, that is sand, is an insulator. Glass is also like the same constituent material. So glass, silica,
Okay.
sand, these all are insulators. That's why they would be termed as insulators. And the other one would be conductivity, like better conducting. Carbon
Okay.
fibers are made of graphite.
Okay.
Fine.
Okay, madam. Means constituent we have to see first.
Yeah,
What is made of that? Based on this. Okay.
actually. The main property of
Okay,
the
madam. Right.
material would remain the same. We are only changing forms to improve performance as per our requirements. So basic physical properties will all remain the same.
Okay, okay.
Fine. And the other one, which we're talking about, the difference between graphite and carbon fiber. So, the most commonly used fibers are made of carbon. I'm working in this field from around 4 years, and I've never come across graphite fibers because they're more costly, and the like their performance is almost similar to carbon fibers, but the difference in their prices are quite high. So if you're trying to make a carbon fiber, it is a easier process, and the percentage of carbon in carbon fiber is only 90 to 95%. But when we move towards graphite fiber, then the percentage of carbon in them is around 100%. I mean, it's around 99.9999%. So that's why both of them differ, and the one which will have more purity would definitely be more crystalline. So that's the reason crystallinity differs in both the cases. As you have more impurities, then crystallinity will start decreasing.
Yes, yes, yeah.
Right? Any other question? The rest of the people, do you have some doubts?
Good evening,
Hello,
madam.
ma'am.
Good evening. Yeah, Arun, you're not audible.
Yeah, I thought. Okay, madam. So, good evening, madam. I missed last Monday. So, could you please
Okay.
brief us what happened in last Monday?
See, this doubt solving session is only about the doubts which you post in doubt solving forum, which is there on that NPTEL website. So the previous four questions, I discussed those in last doubt solving session. So I can discuss them again right now. This uh, this question was not clear, so. Yeah, this one was normal doubt, which was regarding a question which was there in assignment number 0. Then in this one, he asked that cement composites are fibrous or particulate. So in this, I explained that the composites can be of three major categories. One would be they have continuous fibers. One would be they'll have discontinuous fibers, but their size would be comparatively longer. That is around 10 centimeter, 13 centimeter, even 3 centimeter, 2 centimeter. But fiber length would be there. And the third category would be particulate composite. So in that, small particles would be dispersed in the matrix medium so that we provide appropriate appropriate strength which is required, and the major properties. For example, in cements, we have heat resistance which we need to see. Just a second, I'll open that. So So in this, I've said that cements are particulate composites because cements have matrix medium, while small particles of ceramics are dispersed in the entire media, so that their overall heat insulation properties are higher, and that's why like cements would be particulate composites. Um, In this one, they've asked that is it possible to have liquid composites? So yes, research is going on, but in normal applications, when we see a composite, it would have fibers reinforced in a matrix material. So initially the matrix material is something similar to a glue. It is there in molten form. Then after we process the composite completely, it turns into a solid composite. Only after that we have enhanced mechanical strength. And that's why most of the composites we normally come across as solids. However, it is possible to have liquid composites. Composite is nothing but two or three constituents which are mixed uniformly together. Like at macroscopic level, they are uniform and their properties are enhanced version of both of these materials. For example, they'll take strength from the reinforcement, but they'll take heat resistance from the matrix material. So we get the final property of the composite, which will include best properties of reinforcement as well as the matrix. So, and in this one, they've asked that this one was the question in which HPP fiber strength was discussed. So in that, Nachiketa discusses that if strain rate suddenly increases, then the modulus of HPP fibers is also high. So in this, I clarified that the sudden increase in strain rate is just that we suddenly apply a lot of force. That is something similar to an impulse. So when we give impulse or the like amount of elongation you are giving per minute is very high, then that would be considered as a high strain rate. While the one in which we are steadily elongating the material, that is few millimeters per minute, then that would be low strain rate. So in case of HPP fibers, they'll suddenly able to bear all the load which is applied in short amount of time. And that's why for bulletproof jackets and at applications which have demands that the material should suddenly grasp all the energy which is bombarded towards it and still remain in the original position, then for those applications HPP fibers could be effectively used. Okay, and I also discussed assignment 0 of the 0th week. That was quite simple, so I don't think it's required to discuss it again. Do you want me to discuss assignment 02? There were just 5 questions.
No, madam. Thank you,
Fine.
madam.
Okay. Nankumar, now you can ask. You also had a doubt, right?
Good evening, ma'am.
Good evening.
Application-wise, what is difference between carbon fiber composite and graphite fiber composite?
See, carbon
Meaning,
fiber
with respect to properties.
Okay, so let's search the properties of carbon fiber and graphite fiber. So, carbon fiber and graphite fiber properties. Okay, if you want to find properties or predict performances of any particular fiber, this is the simplest method you can use. Okay, so as senior. Yeah, it's here. For example, it's given here. This is graphite fiber and its E11 is 207 gigapascal. Now here in presentation I've included uh, the longitudinal modulus and all the other properties of carbon fiber. Well, this we have of graphite fiber. So we can take it from here and compare. So you can see this E1, it's the longitudinal modulus. Its value for graphite fiber is 207 gigapascal, while this for here is 230 gigapascal. So we can see the longitudinal modulus for carbon fiber is comparatively higher than this given graphite fiber. Then for transverse modulus, it's 20, this is 1, this is 17. So when we talk about transverse properties, then this graphite fiber will perform in a better way. Why is it so? Because carbon fiber will have less purity in terms of carbon, so its bonding with epoxy matrix would comparatively be lower. Or you can say crystallinity is also lower in case of carbon fiber. So that's why when we talk about the properties which are not along the direction of the fiber, then in that case, graphite fiber, we can see here it's performing better as compared to this. You can't actually come to a common conclusion. These property will vary with the grade of carbon fiber, the manufacture of that carbon fiber, the manufacture of that graphite fiber. But yes, from this example which we are seeing, application orientation wise, if we want to choose between this graphite fiber and carbon fiber. So for performance applications which only involves force application in one direction, that is something like you're making a pillar out of this composite and you're placing something over it. Uh, or you're making a bridge structure, it's a straight chain and there are tensile loads at both the direction. So this is one application. So one would be we are having a bridge chain out of composite, it's getting tension from both the directions. So in that case, if you are trying to choose between graphite fiber and carbon fiber, you will choose carbon fiber because its longitudinal modulus is higher. That is, even if you apply sudden strength, then this carbon fiber would not fail because it can go up till 230 like newtons and it will only give a elongation of 1%. But in case of graphite fiber, it can only go up till 207 newtons. So one can be this. But if you want other applications, for instance, there are two plates of this kind and we have a joint in between. And we need to stretch it like this such that there would be shear stresses generated in the system. Then in that case, you'll prefer graphite fiber because its transverse properties are better. Or even in applications in which you have load applications from both the directions. For instance, there, what can be the possible example? A common example in which force is applied from both the directions. Uh, For example, flexural, like if you are trying to check the flexibility of the composite or manufacture composite, which can even be flexible. That is, if we suddenly apply tension from both ends or we apply compression from both ends, then there would be some transverse stresses generated in the system with time. So in that cases, graphite fiber would be preferred over carbon fiber. So, based on the applications and the requirements for those particular applications, you can choose between the two, whichever purpose you need to solve. Am I clear? We can come up with better examples. Right now, at the moment, I don't. In the next doubt solving session, I can include it. So, Nankumar, make sure to attend the next Monday session. I'll definitely include your question into that session list.
Sure, ma'am, sure.
Okay. Anyone else? You have some question?
Madam, you have shown some images just before. May I know how
Yeah.
those images are captured?
Okay. Yeah, this FESCM images, these.
Yeah. Yes, madam.
Okay. So there is one like sophisticated analytical technique which is known as FESCM. So it stands for scanning electron microscopy. In that, we first apply a gold, like a very thin gold layer on this particular sample. Then we focus it with the rays from that particular instrument, and then we adjust contrast between these materials. So, based on the composition of each and every material, they'll have different contrast, which is simple image processing, and we'll be able to figure out the interactions between each and every components present in that particular image. So we can see this image, we can increase magnification as it's a microscope. So main purpose is magnification. But the main importance of FESEM is it will magnify the material, and it will also give high contrast so that the bonding or the interaction between two or more surfaces can be studied in detail. So we have enlarged this image here. This was the image which was used for evaluating the air voids which are present between the bonding between carbon fibers and the matrix. This is cross section of the carbon fiber or glass fiber, and this is again another cross section. We have these glass fibers, and this is the matrix material. So, and these are the air voids. So we can see there are different contrasts for different constituents, and thus everything which is happening inside can be like seen clearly. There are even FESEMs in which we can have dynamic testing. That is, they place the sample, apply load, and then record that sample with proper contrast. So we can see cracks generating, find the crack lengths, and then estimate fracture toughness and everything more accurately. So this is the only importance of this particular machine. It's a very commonly used characterization technique. Was I able to answer your doubt, Arun?
Yeah, yes, madam. Yes, madam. What is the specimen size, madam? Usually used for testing.
5 mm, it's a cube of the size 5 mm. So 5
Okay,
mm,
madam.
5 mm, 5 mm. And it needs to be
It involves.
conditioned. So moisture is removed for around 2 days, then it's kept in a desiccator, and only after that it is coated with a gold layer, which is known as gold spluttering, and after that we place it into that machine. So we'll obtain these contrast as per our requirements.
Yeah, thank you, ma'am. Do you check the fiber alone and matrix alone, or you check both fiber and matrix?
If you want to check fiber alone, you'll only place fiber into that machine. If you want to check matrix alone, you'll only place, for instance, this. Can you see this? This is
Yes.
how matrix looks like when only matrix is solidified. So this is a matrix plate. So we can see the size is similar to this one. We'll just we'll just place it, we'll cut it in 5 mm cross 5 mm cross 5 mm cubes, then we'll place it into FESEM machine, and then try to see the contrast. As this is homogeneous material, I don't think we'll get a lot of contrast. If there are two or more constituents present together, then we can study interactions using FESEM. So it's quite necessary to place two or three constituents together. Then there is another part of FESEM, that is EDAX. In that, they measure the percentage of particular atom which is present in this particular sample. For example, if you are trying to measure a carbon epoxy composite, so in that case, the percentage of carbon, percentage of impurities in the form of silicon, oxygen, nitrogen, fluorine, all of these would be given in percentage, and there would also be peaks. So using that, you can even like calculate what would be the percentage of each and every element present in your sample.
Thank you. Thank you, madam.
Okay. Are there any more doubts? Subhash, Sandeep, Kamal, was today's session clear to you?
Yes, ma'am.
Yes.
Okay, fine then. Can we end this meeting?
Yes, ma'am.